T-minus 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hello and welcome to Honey Badger 3D Print and Paint. Today, what do we have, guys and dolls? We have a printer and a video for you guys that has been, I think, about 2.5 years in the making. So about 2 years ago, me and Mike went to the TCT show in Birmingham, and whilst we were there, we met GooFoo, and GooFoo had some really cool looking machines. Like I really liked their machines, and they're super. They were nice looking. They sort of reminded me a little bit of an Ultimaker. And then they said what they could do, and I was like, really? Now at the time, the channel was really still super small, so we were still only about. In fact, at the time, I think we were less than 100 people watching the channel. So obviously, we did not get any look in at all as to whether or not we were going to be able to like get one of these printers for review. There wasn't even really a conversation about it. As it was, we actually went to the TCT show to film. All of our camera equipment died on us. All of our microphones died on us, and we ended up just like not being able to do anything. Do you know what I mean? Like we just ended up scrapping all of the footage that we had. It was a real disappointment. What wasn't a disappointment was getting a contact over at GooFoo. Now, recently, as you've seen on the channel, we've had a real surge of subs. So if you are not liked and subscribed to the channel already, please, please, please like and subscribe. We're so close now to getting to 2,500. And when we get to 2,500, we've already got a couple of people lined up who want to be doing giveaways with us, and we'll do a competition and all that kind of good stuff, and see if we can drive that a little bit further. So, without further ado, let's see how the hell I get this out of this box. So, just for some context, this the gross weight of this is 29 kilos. The corners of the box are reinforced cardboard with steel inside, so I can't cut through that. So I have genuinely no idea. I mean, I can't even bend this lid. Like it's not working. So let's get my gay little step ladder out so that we can take the stuff out of the top first. It was brilliant when we built this desk because it means we've got loads more space and all of this stuff. It's really cool, but it also means that now we have to sort of get on a little step ladder so that we can reach high things. So what do we have in the box? So for a start, we've got a bunch of pieces of acrylic. I assume that we have to build the top box for this. I assume we have to build the top box. This is the bed. So just before we'll get into the sort of full specs of this in a second, but what we're looking at the moment is a 200 by 200 by 200 build volume. Obviously slightly smaller than an Ender, which, all right, that's not ideal necessarily, but we definitely 1 second, guys. Just let me make sure that everything's cool on YouTube. Oh, and
yeah, it is.
Yeah, cool. Okay, brilliant. So, okay, so yeah, so we've got some instructions that are actually in English, which is always nice.
And colour.
And colour. They're a bit screwed up. Not really sort of very glossy or anything. Same drills with this. This is telling us how we build our top box, and then we have spare parts for the housing. So this, hold on, let's see if I can get this in front of here. This is what we all came for, the 400-degree hot end that goes on this machine. So that we'll look at in a minute, but we won't be printing with that in this video. So we'll do a follow-up review where we review the machine as a whole. We'll do an actual tutorial video on how you change this, and we're also going to be printing some high temperature materials. So definitely let us know what kind of materials, what type of high temp you'd like to see us doing. This is okay. This is sort of regular stuff. So this is completely impregnable. Oh, they all come in anti-stat bags. Oh, a thingy.
Nozzle one block there?
So hold on, what does it say you get in the box? You get positioning block of proximity switch, cool. Side cutter, ejector rod, which I assume is this, a hex wrench, Allen keys, small needle, and a USB 4 gig. I'm not sure why any of those need to be in an anti-stat bag, but they're the side cutters. Do we get special Gucci? No, just checking. Just generic ones. They're just normal side cutters. Okay, cool. That was in that bag. That's all that's in that bag. So we get some really long Allen keys. A positioning block, whatever that is. So I guess we are going to have to read the instructions, and a couple of nozzle things. This is a filament tube, which one would assume is, a PFTE. It is a clear PFTE, so I don't know if that means that it's like a special high temperature one, because most of the ones that I see, Capricorn is blue, and then the other ones are sort of like opaque.
Yeah.
Don't know if it makes a difference or not. Right, we've got USB cable for connecting to the PC, power plug. Thank you very much. Yes, we have new signs. New sign, and there is also another new sign here, but this box is giant and you just can't see it. So, oh, what's this? This looks like a spool holder thingy. And then the first bit of foam comes out. Cool. Oh, this is going to be very hard to get out. Well, the first bit of good news is that it's built, so I don't have to try and find any of the screws. The first bit of interesting news is this is 29 kilos. How am I supposed to get this out of the freaking box? Oh, I don't even think I've got enough. Like, I don't think I've got enough up. Oh yeah, one-handed. That was an ask. I nearly cracked myself live on YouTube. Okay, so I think what we're going to have to do is pitch this on its side. So pitch this on its side first. All right. Let me move this stuff. Move all of that out of the way. All right, and then we're going to slide to the right, slide to the left. Yeah, you're going to have to take that with you. You can't just leave it. Lift higher, higher. Think high thoughts. Think high thoughts. And then that's just the first layer. This is now layer number 2. Do you want to help me with this, or have you just given up now? That was all the help I was getting, was it? Right. Ready? Cool. Come on. Yeah. This is where it genuinely. Oh, it's so tight in here. This is where, like, it just releases and I fling myself across the garage. There we go. Go on. Got it. It's really heavy everywhere. Right. Okay. Hold on. Okay. Oh, it was so odd. Yeah. Yeah. I cannot argue with the packaging. That was well packed. For such a small machine. Oh, come on. Up, round, up, there. Oh. Oh, new signpost. Ta-da! Right. Nice. We open. Oh, okay. We open the little door, and then does this come out? It must come out. This must just some there. First piece out. So, as with a lot of... Oh, hold on. Yes, that was incredibly satisfying. As with a lot of pre-built machines, these in here, you can see these red... Hold on, let me make that big. There we go. So you can see in here these red parts. So these red parts are stopper blocks. They stop your machine, your tool head from moving backwards and forwards, up and down. Why is that so wonky?
I don't know.
How have you done that?
Well, I haven't.
Well, that's not true, because I haven't done it. It's very nice looking, I'll say that much. Like, it's very nice looking. That's still wonky.
Yeah, I don't know why.
Have you done one of the legs wrong?
No.
Well, my garage is level, so I don't...
I think it is.
Well, it is. Anyway, they've done these red blocks, so these stop your tool head from moving too much left and right, up and down. I'm going to have to flip it around so that I can get in there with the side cutters and remove all of those. Switch camera. Switch camera. Right. 1, 2. Oh, they're Gucci ones as well. So these are like hold on. These are like, where are we going? These are like silicone jobbies that sort of sit over the linear rail. I like this. All right. I've got one there. We've got another one this side. We've got another one this side. So as I say, this is to stop any feedback from stepper motors if the tool head moves in transit, and it's also to stop too much damage. I mean, to be clear, I cannot argue with the packing quality that they've put a lot of effort into that packing. So now the question is, and it's a fun question, is how do you get that bottom bit of foam out? Does it just... Nope. I don't see how you get that out. You must have to turn that on. You must have to turn that on. Like you must have to. There's a little clip that I assume holds this up once you've fitted the top piece. So if I just show you the inside of this to the best of my ability, like this. And then like this. Oh, there we go. Right, so as you can see, X is a linear rail. Z has 2 linear rails that are inside this casing here. Y is actually linear rods. Interesting choices all round. So first things first, we find my extra long power cable. Yes, I will turn it on and then lift it. I was just seeing if there was an easier way to do it. And there isn't. Plug in. Let's see if it explodes. Hold on, we'll get back here. Trying to pull that shot out a little bit just so that you can get a picture of what the or move it down a touch. Ready? And oh, Jesus Christ!
Oh, that's nice.
Oh, it lights up quite a lot.
Colour screen.
Colour screen. All right. Let's take a little look and see how we're doing. So, in English, always a nice touch. Back, tools, manual. There we go. Z moves. Bed's a little dirty. So I don't know if anyone can hear, but this definitely sounds like this definitely sounds like it's on silent steppers. So I will check the spec in a second. But that moved. Come on. Ah, there There we go. Well, that's very nice. Oh, I like the look of that. So let's very quickly go through the specs of this. So we are, as I said before, 200 by 200 by 200 build volume. A little small. The stock Hotend goes to 260. It is direct drive. It has an auto bed leveling sensor here, so it is auto bed leveling. It's got a full touch screen, which is color. We are just about to build the enclosure lid, which will sit nicely on the top there. It comes with all the usual garb. All I would, I mean, it's nice. It's nice looking. So I suppose at this point, it's very important to address price, because that's going to upset some people. So the 400-degree Hotend that is in this mystery container is actually an extra that you buy. If you buy the 400-degree Hotend, then this printer will set you back 1,500 US pesos. The door is plastic. Just to answer that question, for pounds, that's about 1,000 to just over £1,000. Now, I want to be clear that if you are buying the machine with the 400-degree Hotend, which, if I'm willfully honest, is really the only reason I could see you buying this machine, £1,000 for a machine that goes up to 400 degrees is fully enclosed. I mean, it's not bad.
And has lights inside.
And has lights inside, yeah. That's not terrible, if I'm willfully honest. This is not necessarily. We have to be careful, because what happens on a lot of channels and what happens with a lot of printers is the first thing anybody compares it to is an ender. This isn't an ender. It's not. That's not what it's for. That's not what it was designed to compete with. This is an entry-level industrial machine at this stage. It's just got a similar size bed. It's just got a similar size bed at the end of the day. So, so over here we have got. So there is like a. So I think this has got a filament detector on it. You know, it looks like it on the back. It does indeed. It's got a filament run-out detector. This must just sit in there. It doesn't need to. It doesn't need to be held in place with a push fitting on this side, because you've got to bear in mind this is a Titan on here, or it's not a Titan, but it's a direct drive, so it's pulling directly from the Hotend, so it doesn't matter. I haven't used their plug because it's quite short. We've got our longer test lead on there. This is spare parts for housing. So let's open this up. Well, this looks like the world's most complicated jigsaw puzzle. Oh no, there's a little bag with tiny screws in. I'm going to lose all of these. Oh, they're going to go everywhere. Oh no. Oh, there's so many. Oh, okay. Right, fine. Let's see if this goes horribly. This here is it's a bed. What's strange is there's already a bed on it. So there's this aluminium plate and this magnetic piece here. This magnetic piece fits onto there quite nicely. So I am confused. Well, it could be. I'm wondering whether or not it's magnetic to hold. Oh, it is. Yeah. Right. Okay. So the way this works is this. Thank you very much, Mr. Diesel, Mr. and Mrs. Diesel, even. So this is the sheet. It's sheet metal underneath, and then you've got a magnetic flex sheet that goes on top of that, and then this steel sheet fits on top of this piece here, which is also magnetic. So it. Cool, Christ. Okay, that is, once that's down, that is not going anywhere. So that's got two magnets on it. Interesting choice. I know from past experience with different magnetic beds, I've had varying degrees of success with them. I think it's fair to say. So the spring steel that's on, say, a Prusa is really good and has always worked really well for me. I've not lost any magnetic any magnetism from it. It's worked pretty well. I had spring steel on my Airy one, and that did not work well. The magnets on it were abysmal. And when I back in the day when I had an Ender 3, I'm pretty sure I put a magnetic build plate on that as well, and I was once again woefully underwhelmed. So this is the acrylic hood. I'm guessing they're just trying to save a little bit on shipping with this, so that it's just not this giant box. I mean, it is already a giant box, but giant.
It needs to be any more giant.
Yeah, but they did a decent job of trying to make sure it didn't get any bigger. So this acrylic is actually perfect. No scratches, nothing like that. Nice and clean. All the edges are actually beveled as well. With running both beds, I wonder how the heat conduct will take. An excellent question. I mean, it is so. It's a heat. So let me just check if it's an aluminium heat plate or not. Does it actually say? Inductive, full aluminium, high wind rails. So FYI, these are MGN 15 genuine high wind rails. And it is a silicone heat bed underneath. Hey, Marissa. So I would not be too concerned about heat transfer with a silicone heat bed. Marissa, you'll be happy to know that I have many tiny screws. I'm going to lose all of them. Okay, so God help me. Let's see if we can actually follow the instructions on this. So, I mean, they're not horrendous, but at the same time, that doesn't look right, does it? This one must go here, like this. Yes. So that's when we go. Thank you very much. Yes, we've been working very hard on it. We've been working on the studio today, actually. So we've been finishing signs, and oh, that was nearly the first screw gone. We all saw it. Oh God, it doesn't actually stay in. Oh, this is my idea of hell. What did I do to deserve this, other than the obvious? Okay, nobody panic, but the first screw's in. Everybody keep it cool. So this is actually, I mean, to be clear, I haven't actually looked at the instructions yet, which we'll see whether or not that's a good idea after I've finished. In fact, I'm going to do it without instructions. Boom. Michael, could you find those? Please don't lose this. I was so confident, and I just, as I threw it, I was like, why? Why would you do that? Easily one of the stupidest things I've done.
Well, I don't know. It was the Factory 260 video where you pelted the models off the side of the table and then we had to reshoot it.
Yeah, that wasn't ideal. Our editor said a lot of hurtful things to me when I did that. He even put it in the video, I think, that we really needed to reshoot it and we couldn't because I'd smashed them to pieces. Right. So I suppose the only thing that I would point out is there does appear to be these thingies.
Would you like me to look at the instructions?
No! It's all right, they go in there. Found where they go. They go in these parts. I was so
I can't actually read.
Yeah, Mike can't read. Glasses are just for show.
They just make me look more intelligent.
Yeah. All right. I assume these are like locator things so that when it goes on, but as I didn't look at the instructions, we'll just never know. It'll just be a surprise. So these do just seem to go on quite nicely, actually. So I'm loving the fact that none of these are like sort of ultra sharp or anything. Like they've been beveled out, so so they're not going to cut. Like they've been machined really nicely. And hey, Richard. Oh no. That's it. There we go.
I actually really like my sign.
Can we get a preheat mic while James finishes? We can certainly give it a go. Oh, well, this is just my idea of hell. Why won't this work? Oh my God. Why won't you do what you're supposed to do? Well, this was sent here to torture me. This is some sort of cruel joke. Oh, what is wrong with you? Oh, that went away. Who wants to bet they didn't give us any spares? Oh dear.
It's really slow doing the preheat.
It's slow doing the
I
preheat.
literally do that many presses.
Is there not like a Integra thing that you can change?
No.
Is there not a preheat where you can like select a certain... Hold on.
No.
Let's have a little look. Oh yeah. It's annoying.
Yeah, because you've got to press it like 200 times.
I mean, I haven't got to press it 200 times. It's not a problem for me. Oh, good Lord. Yes, success. I absolutely agree, Marissa. I turned off. I wholly disagree with any printer company who thinks it's appropriate to send me lots of tiny, tiny screws to lose.
Yeah, but they always think they're sending printers to normal people.
There is that. Fingers crossed there's some spares, because I have definitely for extra nuts. Thank you very much, Makers Hub. So for anyone interested on what we do with the donations, after we've taken out our initial stripper money, we then use all of the donations to go to new machines. So and new content for you guys. So for example, for this, we're going to need to buy a whole bunch of industrial grade filaments. So that'll probably be sort of 150 quid's worth of filaments that we end up buying. So it's not
I'll just put the camera.
all right, hold on. So okay. Let's carry on screwing this down. So to be fair, this is actually relatively self-explanatory. So I didn't actually need the instructions.
Doesn't show up your preheat on the front screen.
It doesn't show it.
No, that's
Okay.
annoying.
Well, yeah. Oh dear. Small screws, Richard, are genuinely my. I just feel like
It has to be small in order. Let's be fun, like better. Like you drop and lose Allen keys.
I've dropped and lost a printer before now, I think. Oh, I found another screw. But that wasn't what I was looking for. Well, if anyone's curious as to where that nut went, it is gone. So let's fingers crossed that they do give us some spares, because that is not here anymore. Either that or we're going to have one screw missing. The good news is that this is not a structural box, so so it's not the end of the world. And as well, and I want to be very clear about this, it's also Mike's machine. So so Mike will be the one using this day in, day out. So the fact that one of the screws is missing is definitely a him problem, not a me problem.
There's a fly in the printer.
There's a fly in what?
In the printer.
There's a fly in the printer. Oh my God, there is.
What is that?
So the box, Marissa, is because this this machine does a 400-degree hot end. It is so that you can print enclosed. So so all it's really there to do is to prevent draft. That's all it's for. So it's just so when you're using things like ABS and nylons and things like that, you're just trying to make sure that you can prevent any cold air from moving around, because cold air moving around your printer will cause a warp on some higher temperature materials. This isn't a heated build chamber. Just to be really clear, I did need that nut that I have dropped, so that's bad. Oh, I'm not going to be able to find it. It's down here somewhere.
Oh, is this it?
What? Is it? It's not a heated chamber, no. Good Lord!
That's because I wear glasses.
That's because Mike wears glasses. He can't read, but he can find nuts. Wait, what? No. Well, yeah. Okay. I made a thing. Right. So. All right. It's like a little Jenga puzzle at the back here. There we go. Right. So that goes like that, and then those. Well, I put this one in upside down. Yeah, I'm gonna have to take that off. So, so I don't know if you can see. Let's see if we can put that on a bit closer up. So on this, there are these corner pieces here. These locate inside the top of the printer, and they stop that top hatch from moving. Quite a nice little touch. Would be even a nicer touch if I'd have fitted that one correctly and made it so the nut was around the right side, which I didn't.
Hello,
So,
Jerry.
hey, Jerry. Guys, Jerry is super freaking close to to getting his. Oh, hold on. Oh, let's turn that round. Okay. Jerry is really close to getting 2,500 subs. So if you're not already subscribed to Jerry's channel, please, please, please go over, like, subscribe. His videos and his hangouts are really, really cool. And definitely a guy you should be checking out. Jerry was really one of the first people in the sort of maker community that we met when the channel was really starting to take off. And yeah, he was really, really helpful to us, introduced us to a bunch of people. Actually, he was the person who introduced us to Makers Hub. And I mean, Makers Hub has been absolutely amazing. So there we go. So that locates, and then that stops that from moving all over the place. Those are my dirty fingerprints all over it now, but that's fine. Spool holder. Spool holder. Oh, okay, locks into place. Quite like that. So let's just take a look and see if there's anything. When you finish the first steps, remember you need to refresh the firmware and or take a firmware refreshing. You can find, but if you replace it,
you also need to reseat the burden tube.
Who I do? Oh yeah. Oh dear. Oh, hold on. I think that's what that's for. So there's like a little here we go. There's like a little clip thing on here that I think just keeps the Bowden tube and the and there we go, and the cables just nice and out of the way. So there's then like a channel. Oh, that didn't work, did it? Okay, let's do that while it's up here then. No. Maybe that way. That's better. Right. Okay, cool. So the USB key that you get is quite nice. So the USB key is very, very similar to the one you get with an artillery. So it's unbranded, obviously, but you get a full-size USB key. Does that mean that it's a USB interface? It must be. Yeah. So it's a full Type A down the side here and a Type Square. I don't remember. Whatever this is, whatever these printer cables are, I can never remember. How big of an area do I need? Do I need to set up for this? Oh, so the actual machine size, as in the physical dimensions of the machine, are that's packaged right. So it's 396 by 393 by 470. So it's a decent size. But I suppose the thing to bear in mind is that yeah, you will need a bit of extra space for the spool holder on the back. Have you got a tape measure over there? Or have I got one over here? Yeah?
That went well.
So working space, you would need 500 mil front to back. You need, with the hood on, 630 mil. And then just under 400 on the X. I'm going to plug this into the computer and potentially give the entire Chinese government access to my PC. Let's take a look and see what we get on the USB stick. So on the USB drive, we get the user manuals, a filament loading, a filament unloading, and a platform calibration video, a GooFoo 3D, typing on a phone watching TV. So there's a Hotend unit replacement video. So when you want to change that, there's a slicer profile, a Wi-Fi module RAR. What is that? What, it has Wi-Fi? Does it have Wi-Fi? Simple, convenient, fast, fully aluminium, high wind rails, top cover. Well, if it does have Wi-Fi, it doesn't mention it online. All right, okay, well, we'll see what that is as part of the review. They give you a filament loading, filament unloading, and a platform calibration video.
Why don't we get a little stick?
Because you get fingers. Okay, so it just does its jam. Oh, okay. This is a lot of points that it triggers. Okay, let's go and have a let's press some buttons, people. Right. So, let's have a look. So turn that off. Right. So we go down here to leveling, and then I don't know what that means. So every time an end stop's triggered, it beeps in a really annoying way.
There is a button there for sound, so I think you can probably turn sounds off.
Oh, so there is. There we go. Sounds are off. I like that. Okay. Well, it's doing it. That Bowden tube's come out again. I'm guessing that's probably going to keep doing that until it's got filament in it. A little bit annoying. Trying to pass me the filament. Yeah, so to be fair, the lighting in there is really, really good. You can see everything. It's right at the front. The lighting thing is right at the front here. So it's beaming itself right onto where the hot end is. So for anyone curious, we are using Sunlu PLA. We're using that because, and I want to be very clear about this, that is what was in my garage. I'll clearly let go at the end of this at some point. This is going to be a problem. Well, this is not how I wanted this to go. Okay, it's all right. I figured it out. Bowden G came out again. Right. So it's definitely got a filament sensor in the back because I literally just heard it click. So I'll push this through. It's got a hell of a leveling system. No, because I need to push it in once I get to the thing. The Bowden tube doesn't do anything, don't forget. It's a decent mesh. It's definitely a decent mesh, but it is smashing through it, like. Right. So this goes in on the hot end like that. Let's look at loading filament, shall we? Just to be clear, you can literally just tap it and it goes to like 212 degrees. So he spent a long time doing that for no reason.
I set it at before 212.
Right, so we'll just wait for that to heat up. Heating up pretty quickly, actually. It's doing a decent job of that. Give that a few seconds to get up to temperature. As you're all staring at the back of my head. So so Mr. Diesel, so for leveling, it's using a capacitive sensor, and it's just doing a regular it's just doing a regular mesh light. It's not doing anything wildly special. It's just doing, I think it says it's 16 points. It's quite a lot. So I will be showing you the 400-degree hot end today, but I won't be fitting it today. The main reason for that is just because it's a 400-degree hot end, and I really want to make sure that I fit that correctly the first time. Right, okay, so right, let's go back here. So I am just right, it's currently unloading filament. Yeah, 400 degrees C is obviously cool. Oh, there we go. That's taken the filament in now. And filament is coming out. Woo! It's very hot. There we go. Right. So let's take a look and see what we've got. So first of all, as I said before, it looks like we have a GooFoo branded slicer. So we will install the GooFoo branded slicer and then we will see what we're working with. It does come with a slicer profile. I don't really use slicer either, so I'm not particularly interested in either of those. Take it that fan on the bottom is for venting out. It is indeed. So I'm just looking to see whether or not it's vented or whether or not it's filtered. Does it say anything on there? It does not currently say anything on there. So I'm just trying to see whether or not. Yeah, so it's got a filter on there, but I'm going to be honest with you and say that doesn't look like it's a HEPA filter or anything like that. It just looks like it's a it's just got like a fan grill on it that's got some cushioning. Right, so we're going to run GooFoo 3D. And then in the interest of expediency, I'm going to load up a calibration cube and we'll see how this does out of the box with no actual calibration, which is always an interesting one. So we have the Mido, add printer. Okay, so this is very obviously an early branch of Cura. Does it tell us which? No. Okay, right. Okay, we've got some interesting. In fact, why don't I share my screen and then I can show you what we're working with. Share my screen. So this is what we're working with at the moment. You can see here that we've got a few materials. Some of those are known to me and some of them aren't. So Polymaker I know, Verbatim I know, Fiberology, I know, but everything else, no idea. We've also got 3 random brands at the bottom there. So we're just going to pick a regular PLA on there. There we go. So this is definitely Cura that we've got. It's in, let's go for a, okay. So it's literally just saying that you can go 1.5. It's implying you can go down to a 0.5. I challenge that's probably not true. But let's bring in a calibration cube. There we go. We shouldn't need supports, so turn that off. We've got no experimental stuff on here, so this is obviously an early branch. We're doing a skirt, that's fine. Our infill's 20%. Yeah, cool. Right, well, we're not going to play about with this too much then. We are just going to prepare it, save it to the drive, and then we're going to see how it does. Plug that into the side there. So one thing I will say, I do not like it when you have USB sticks that plug in down the side. They should plug in at the front. If you were running these in a farm situation, honestly, it's going to cause you issues. So so let's just turn off that screen share quickly and move back. There we go. Right, so let's take a little butcher's and see what this does. So we've got, there's the calibration cube. You click play and it's doing something. So I haven't set the Z offset on this. It's gone around and done its little calibration jobby. But oh, you can turn the light on and off. Cool. So I guess, yeah, you can change your temperatures, you can change millimeters per second, the part cooling fan, and you can change the flow rate from there. I'm very curious to see how this deals with, how this does its bed leveling, right? It's leveled the bed, it's gone round and done stuff, but I don't really see, I'm not really seeing a way that you can adjust the Z offset. So this is on there. Yeah, it's fine. Well, let's see what it does, chaps. Right, so let's pull this back and let's, while we are waiting, how's the job going, Mike?
Same old, same old.
Same old, same old. Yeah. For those of you who don't know, Mike works for a local council, and he does a lot of sort of repair work and general stuff like that. A lot of construction. And for probably the last 6 months, Mike's been working the best part of 14-hour days. It means that it's very, very difficult for him to do really anything other than eat, sleep, poop, and then go back to work again.
And then come here on a Saturday.
And then come here on a Saturday. So this 400-degree Hotend. Let's pull ourselves here and see if I can show you what it looks like. Like, this is a unit. So this is a big brass heat block. Look at the size of that. The size of the heat block on this is insane. A big, like, braided cabled thermistor there, and then a really beefy heat cartridge as well.
Feels like we shouldn't be allowed something like that.
Yeah, so the only thing that I'm going to point out is that that is a brass nozzle on the end of that. I don't understand how. Well, it just looks like a regular Mark 10 nozzle. Oh, hold on, we're about to do something. I've not set the Z offset, so I don't get how it. Like, I'm assuming it goes and does like, oh, it's not even doing a bed level. It's just going in. Well, bugger me. Is that just level?
Is it?
Yeah. Okay. Well, that's level then. So the only other piece that they've given us, to be fair, there is a video. So if I show you the piece they've given us, right? It's not that one. Go back to that. There is this 3D printed piece here. So I don't know if you can see that. Right. So so basically what I assume you're supposed to do is you put this piece here on the nozzle on the bed, and then there are two grub screws here that you can use to lower and raise the capacitive sensor that's on it. So the assumption is that if you can always accurately place the sensor a set distance away from the nozzle, then in theory, it can always know what the Z offset needs to be. Which I'm not going to lie, clever.
What speed is this pen?
I don't know. Let's have a look. So, in the GooFoo slicer, speed 40 millimeters a second. So, not fast. Like at all, actually. Like, really not fast. So, hold on. So, I can't imagine there would be a regular. I'm just curious as to whether or not there's a regular Cura profile for it, or whether it's not a name that I've ever heard before.
The only reason we know this printer is because we see it at the TCT show. As far as we know, it's not available in the UK.
That's an excellent question. 1 second, and I shall tell you. Right, so there is a UK distributor, but they only sell the Tiny and the Tiny Plus. There's an Amazon store where you can buy the Tiny Plus and the Mido, but that is for the US. Interesting. So in Europe, they mainly deal as OEM business, and the customers are selling GooFoo printers under their own brand. So you may have seen this machine before, but you would have seen it under a different brand. So they make the machine, and then someone else sticks their brand on it. So let me just have a look and see if there is a GooFoo. There is not. I didn't think there would be. So what we'll probably do is, I mean, I've said before. Oh yeah, it's quiet. I mean, I'm standing. So I'm standing right, like up against it now, and I mean, a minor whir, but nothing major. These are branded high-wind rails as well, guys. So, like, we're not talking cheap parts in this machine at all. It's interesting that they give you two of these leveling things.
Well, I probably know you're going to drop one.
Yeah. So I've now looked at this. Oh shit! So so these two here. Hold on, let me get to the other side. I don't know if you can see, but these are different heights. So one of these must have come out of the Hotend kit. Of the high-end Hotend, and the other one came out of the regular Hotend, and I don't know which one's which. So we have two of these, and we're going to need to label them in a way that doesn't increase the Z height. So we can't label them on the bottom. Yeah, we'll have to just label them on the bottom or on the side or something right on them. So that'll be a fun little one. So Matt, price. So we've already talked about this, but price-wise, they're not cheap. So
So a little bit eyeball.
yeah, so they're about £1,100, brand new. And they're about $1,500 US if you wanted to buy it with the high-end Hotend kit. This is a nice printer on its own. Without the 400-degree Hotend kit, it's a little tricky to justify. There's plenty of other machines that are enclosed, that are auto bed leveling, that have the sensor, that are silent stepper drivers. Maybe not loads sub $1,000 that are that have got sort of linear rails and everything. But I mean that is that's a price, like that's being hold on, my mic's not sitting now. There we go. So that's a price. As I've said, we really have to move away from this mentality where for some reason we want to compare every single where we have every single machine. I'm going to be honest with you, Matt. I'm shocked at the quality. It's fantastic. Like, I mean, we have to wait until the cubes come off to see how this is printed. But I haven't touched anything on this machine. I've loaded Filament. I've put it on. I'm using their slicer, which is a branch of Cura. So we are just going to have to see how this performs with regards to printing the cube. All aluminium shell. It's acrylic on the front. This top box is acrylic, but you'll be printing you'll be printing ABS on this pretty much out of the box if you wanted to. It's very quiet. It's very quiet. I mean, it's putting down that cube, like it is putting down that cube. So 40 millimeters a second, I'll be honest, is slow. But the website does claim that you will be printing up to 300 millimeters a second. That's a very bold claim. A very bold claim. The only thing I would say I'm not happy about is that on this Hotend that you've got a brass nozzle on there. So let me just grab my nozzle removal tool. What is the transparency when looking through the top? The transparency is good. You just can't see anything because the Hotend is huge. No, can't use that. I'll tell you what, we used a little thing that came with. Right, so that is a regular nozzle. And I do like to see that, to be fair to them. To be fair to them, I like to see a regular nozzle where you're not having to buy their nozzles, you're not having to buy bespoke or anything else. You know, you can just you can go out and just buy a nozzle, like. But if we were doing high temperature filaments, I'm gonna be honest and say that that needs to be a high temperature nozzle. So that needs to be something like a Nozzle X or a Ruby nozzle or something like that, because honestly, if you're printing nylon with a brass nozzle, you'll be going through 3 nozzles every single time you want to get on the, every single time you're trying to print anything. It'll cost you a nozzle, a calibration cube, pretty much. As I say, you can see clearly through the lid. It's just because the calibration cube is so small, the whole tool head just covers it. Let me see if I can see from the front here. Yeah, so let's see if we can. Let's see if we can get in. a little closer. Well, that's terrible, isn't it? The image cannot be magnified. Great. Outer ring. No. Hold on. Stop. Stop. Right. You got that. And then you go. Sure auto. What's the name on? Why can't you focus this? Oh, there goes this. And focused. Ha 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 ha! Victory. I mean, I'll not lie. That actually looks pretty good for something that I haven't leveled. Like, good Lord. I can't believe that. So, I mean, when you consider something like a Prusa does have a larger build volume, but it isn't enclosed. It's not an all metal hot end. You can't buy a super high temperature piece for it. I mean, that's doing all right. So 40 millimeters a second, I'd expect it to be doing all right, but that is not bad. So we're obviously going to have to do a pretty in-depth review of this, and we're going to get multiple videos. So so first of all, from the guys that are watching, are there any high temp materials that you would like to see it do? Obviously, we're going to do the likes of ABS, but what would you like to see? Would you like to see carbon fiber? Would you like to see? Do you want to see nylon, PEEK, PSU? I mean, theoretically, all of those things are possible. Sorry, that wasn't me just lashing out violently. There was a fly in here. All of those are possible on something like this. It's direct drive, so we can do TPU. With direct drive and linear rails, I'd be interested what speeds of TPU we could do, because there's loads of machines that can do TPU, but they end up being really slow. You're putting down to like 20 millimeters a second or something. I want to see plastic melt. Brilliant. Radmaster, carbon fiber PC. Let me just have a little look on Filaprint's website, because they list on there all of the the working temperatures of them. So biomaterial, carbon and glass, graphene enhanced, PETGs, black nylons. PC TPEs, TPCs, oh, that's just ABS. Flame retardant PC ABS. PC ABS, PCB, what's that? PCB PBT, I think that one's. No, maybe not. Protopasta PC alloy. Weird. Thermix PR. What do you think? What may you like to do and why? Fast TPU would be interesting. Very true. So, I mean, to be fair, this is a direct drive. It's equivalent to a Titan. So I don't see any specific reason why we couldn't do TPU at a decent speed. So we'll definitely be giving that a go. Carbon fiber PC, we're just going to have to try and find some carbon fiber PC, because I don't see it. Well, they've got polycarbonate. I'm sure they do carbon fiber. They do carbon fiber, but do they do carbon fiber PC? I don't know. Hold on. I just want to see the working temperatures of it. So, protopasta, carbon fiber PETG, carbon fiber PAC. It's really annoying. It's intensely annoying. Carbon fiber PETG. Bunch of carbon fiber PETGs and carbon fiber nylon So carbon fiber nylon, it's saying right, but give me the print temperatures, guys.
Should be on specs, shouldn't it?
Well, one would imagine so, but it's not. Carbon fiber nylon, 600 grams. Oh, really? How annoying. Normally they tell you the oh, hold on. Is this the test conditions? Print temperature 235 to 260. So to be honest, that's well in the wheelhouse. TPU, haven't I? Yeah, it's all right, Ron. I've got some TPU. That's not a problem.
I'm open.
From filaments in Canada from CPE. Okay.
What's the roll file print gave us before?
That was PC. No, damn fly. Oh, honestly, I'm going to become incredibly nylon K. Oh my God, Kevlar filament. I think
Kevlar filament.
I think actually, do you know what? I actually think that that Filaprint do some. I'm sure they do. It's like a glass reinforced thing. Oh no, maybe not then. So hold on. So properties. Biodegradable, glow in the darks, graphene enhanced. I'd be interested in some of those. So graphene enhanced PLAs. They're coming in at what's your print temperatures? I mean, if it's graphene enhanced PLA, one would imagine that we're still looking at sort of relatively normal temperatures. Do you know, I think nylon is only, like, if you want to print actual nylon, I don't even think the temperature, I think things like Peak. So Peak, they've got a carbon fiber Peak that's 233 pounds for a half a kilo spool.
Oh, I don't really want to buy that.
So I don't think we'll be buying that necessarily, but we do need to try and have a word and see if we can get. So
I don't think Filament have even got a print that. Eh?
Peak has a melt temperature of 343 degrees. Therefore, you need all the metal extruder capable of reaching and holding temperatures upwards of 400 degrees or more, depending on your printer. Extruder temperatures are between 380 and 410. A bed temperature of 130. I'm not actually sure what the bed's max temperature is. Oh, the max bed is 120 degrees. So I don't know. We probably can't do carbon fiber Peak. We might be able to do a non-carbon fiber infused one. I'm not sure. What about PSU? PSU is pretty, or PPSU, sorry. No, PSU, yeah, I thought so. Thermax PSU, polysulfane, high temperature aromatic sulfone. Well, I don't know what that's a lot of words. Yeah, yeah. Oh, so extruder temperature 350 to 380. So we could try PSU. Does it have a little bit of over extrusion on the bottom? Is that a little bit discolored as you look at it? It could do, Matt. To be fair, we've not touched anything on it yet. So so we're just going with whatever it says on I mean, you can't actually change the flow rate on this.
You do it on the screen, though, couldn't you?
Yeah, but you don't want to be doing that every single time, surely.
But that's a basic cure.
Oh, here we go. They've just not. There we go. They've just turned off a bunch of stuff. Right, there we go. We've got it all back. Cool. It's all right, Matt. So it's 200 cubed. So it's 200, 200, 200. So it is not the largest machine. I appreciate that. However, if you are printing at these kind of temperatures, I would envision you are not printing giant parts. This is a specialized printer for a specialized purpose. Yeah. This isn't necessarily the kind of machine that you're buying to just use at home because it's cool. Although I suppose you could. And GooFoo do other machines that are larger than this one.
Larger and smaller.
Larger and smaller. I think the tiny comes in at 150. No, sorry, the tiny comes in at a 100 cube and the tiny plus comes in at a 150 cube. There's then this. There's then the Mido Plus, which comes in at 250, I think. And then they go up to, I think, 350 after that. Oh, sorry, it goes to the T1, then the Plus, and then they've got industrial machines,
which are called the Giant and the Max.
Which are called the Giant and the Max. I'll be honest, they've not put a fantastic amount of time and thought into how to name these, but you know, I'll be honest. For £1,000 machine, right? I know that £1,000 is a lot of money, but if you are looking for another machine, have you got prints you're planning to do on this or purely for review? I'm going to be honest and say that I don't actually know yet. So the reason why I say that is that I've never thought of a project that would require super high temperature filaments. So it's just never come up. Like it's never been. I mean, I suppose
sort of stuff we print. We don't print.
Yeah, you know, we print a lot
of parts.
Yeah, we print a lot of models. We print a lot of things like that. I don't think we've ever done a project where you would say, "Oh, yeah, actually, that would really benefit from having, you know, from having like peak parts on it, or PSU, or you know, PPC, or whatever." Oh, that fly! I'm going to get it. I'm going to Mr. Miyagi it with this freaking Allen key. So let's just have a look and see how we're doing.
It looks nice, considering we've done nothing.
Yeah, considering we've not touched this thing yet. That's not bad. It's not bad looking, guys. I've got a replacement Hotend for it. So
I would say the
so as I said before, oh yeah, there we go. So oh look, there we go. This is the 400-degree Hotend that goes on it. As I say, the only thing that's slightly disappointing about that is that it just comes with that regular brass nozzle. We're more than likely going to have to get like a Nozzle X for it or something. At the very least, the stainless steel one, because anything that's carbon fiber enhanced is just going to chew through it. So make a bicycle cup holder. Going to be tricky, Matt, because neither me or Mike own a bike for obvious reasons, in that neither of us really have the capacity fitness-wise to propel ourselves with that level of locomotion.
And I learned to drive.
Yeah, when I learned to drive.
Whenever I wanted to go anywhere, I'd get in a car.
Sinister, sorry, do you mean tungsten as in a nozzle, a tungsten nozzle? I'm assuming you mean a tungsten nozzle. So a 500-degree Hotend. I mean, in theory, I suppose if the parts on this are good to go up to 400 degrees, one would challenge they're probably going to be all right to go up to 500 degrees. The only thing I would say when it comes to going to 500 is the bed and the fact it's a because it's a non-heated enclosure. I would imagine those are the things that are going to be holding you back rather than the Hotend itself. So, for example, if you need 200 degrees on the bed, for example, which some filaments do, or if you need a specialized build surface So I know there are a couple of things out there that have to have like a ceramic build surface or something, and they almost chemically bond to it when it's done. You know, obviously we don't have that on this machine. It's not an industrial machine. It is just a, I mean, no, maybe it is.
This machine would be suited for like a university, something like that.
Yeah,
an engineering department in a university.
Yeah.
See what this is aimed at. Than like a home user.
So what I would say is, because they're giving you because you're giving you a 400-degree hot end and this hot end that's fitted, I'll be honest and say, I feel like that's I feel like you're not going to be able to print PLA or anything or PETG with this. I bet you can't even print ABS with this. This is going to be a hot end that has been specifically designed for high temperature filaments. Yeah. It's a bit like, you know, we've had the conversation before where people go out and they change out their hot end for they change out the throat in their hot end for an all metal hot end, and then they try and print PLA with it and it clogs all the time. And that's because there are tools for specific applications, and that's not what this is for. You know, this 400-degree hot end is for printing at sort of, you know, 300 degrees and above. It's not for printing PLA. Otherwise, why give you two? Why not just fit this as stock and just say hot end goes up to 400 degrees and you can print PLA on it? You know, it's a tool for a purpose. I don't know what a red copper trough is. Didn't know that you wouldn't be able to use just PLA on all metal. Yeah, it's a fairly common issue. So so it's not the case on all machines. Bowdens tend to suffer from it a little bit more than direct drives do. But basically, if you've got an all metal hot end rather than a PFTE lined one, when you're printing at lower temperatures with PLA, they are more prone to clogs. It's that hot because the print's low temp like that. Yeah. More than likely. More than likely, Sinister. So as I say, I mean, this is the regular hot end that's in it now. We're obviously just printing PLA in it. We're almost done. Yeah, we'll do an ABS test on this hot end. Although actually, I'm pretty sure this hot end says that it goes up to like 230, and then it stops. I think it stops at like 230, 240. So I wouldn't do ABS on this one. I'd do ABS on. I'd swap it out for ABS. Could do PETG on this first though. Definitely get a PETG print out of it. Part cooling is a 5010 radial fan at the side that's got a little vent on it. I don't dislike the part cooling fan, but once you start going high temp filaments, you don't use it, you know. So yeah, that signpost looks the nuts, by the way.
What does?
When I was in touch with guys, the 500 wasn't exactly. And you've hit the nail on the head there, Sinister. It's not designed to do that. It's a tool for a certain purpose, which is printing high temp filaments. So when you want to print low temp filaments, you swap out the high temp for a low temp for a low temp hot end. That makes perfect sense to me. That's what you'd have to do. You know, it can't just be that you need to have a higher, you know, that you need a better, you know, you need a better thermistor or whatever. It can't just be a part limitation. It has to be that you know, there's a tool for a certain purpose. This has just started on some of the top layers, I think, so we're almost done. What's the 79%. Interesting is on the front, it's actually got a little readout that tells you what speed it's going at right now. So so whenever you set up your speeds, you'll set your main print speed, then there's your infill, your wall speed, your top and bottom layers and things like that, initial layer speeds and things. This actually tells you on the screen whatever it's going at that exact moment. So it's going, so right now it's going at 20 millimeters a second, and then when it goes to doing the infill, it's moving back up to 40. Yeah, you're right. And again, I mean, if you've got, I mean, so with this, you don't change any of the part cooling or any of the fans. It's just this heater block. It's a new block. It's a new
Huge block.
It's a huge block. Yeah. It's a new thermistor and a new heat cartridge, and it's a new heat sink with a new throat in it. But other than that, you're not changing any of the part cooling. You're not changing any of the any of the heat of the hot end cooling fans or anything like that. You're literally just changing. You're literally just changing the block. I'll be very interested to see how complicated it is. So it's, oh sorry, so it says here that the hot end that's in it goes to 260. Ow! Yeah, so the oh, so it doesn't look like it's not like a hot swap thing. Unplug the terminal and heater of the NTC, replace it, body. Fasten the screws, unplug the yellow, replace it with the red. Oh, okay. So there is a little bit more than just bed leveling's freaking easy. So as I said earlier, so we don't level the bed ultimately. So there are these two little. Let's see if I can get this in front of here. So there are these two little shoes. There we go. These two little shoes pieces. One goes underneath the. It clips onto the end of the sensor, and then this piece butts up against the bottom of the nozzle. You then retighten the tighten the capacitive sensor, and you do not then have to touch the Z offset at all. Don't ask me how. I don't know. But it's essentially saying, I suppose the idea is that the capacitive sensor is set to a specific Z offset. If you move the capacitive sensor up or down so that this part is touching the nozzle and this part is at the bottom of the capacitive sensor, then you know that is where the that is a set amount of Z offset, and it goes over, probes the whole bed, and then it's away. It's got knobs on the bottom. I've no idea what they're for because I haven't touched them. It doesn't look that complicated to change everything over, but you do have to do something on the main board. It looks like you have to change out the because as stock the regular hot end comes with a standard NTC, but this one is a KTC, which is a super high temperature. I say super. It's a high temperature thermistor, so that it doesn't explode. We'll definitely be doing a video on changing the hot end over those. So if it's something that so keep an eye out on the channel for that, because that's going to be an interesting one. But we are coming to the end of this print now, I think. We are at 92%. And I'll tell you what.
It looks good.
It looks good. It looks good. So I think that what you can see on the camera, I think that bottom bit is just the refraction of light on the layers. because when you look at it normally, you can't see that. So I think it's just the way the light is hitting it. I mean, ultimately, this is a 0.15 layer height, and it's doing its print at 40 millimeters a second. So, like, you know, it's lower layer height than we would normally do, and it's a way lower speed. Like, we'd normally be printing at sort of 60 to 80 millimeters a second, and we'd normally be on a 0.2 layer height. So it'll be interesting to see how this does. Where's the filament going in? So so the filament spool holder is on the back. There's a filament run out sensor that it goes through. It goes in through the back of this large block of the acrylic sheeted top, and it's then direct drive, and it's going into kind of like a Titan clone, but it's not a Titan. It reminds me more of when people do, you know, when people do micro Swiss, like a micro Swiss. It doesn't say whether or not it's dual drive, and I can't see anything in it. But looking on the side here, I wouldn't say that that is dual drive. I would say that that's really no different to the extruders that you get on say an Ender, but instead of being a remote, it's a short travel. And one would assume there's no Bowden tube in it. There is a Bowden tube that goes, or there is a PFTE tube or something that goes from the back filament sensor into the top of the thing, but it literally goes into the top. It doesn't go all the way in, because it's essentially a direct drive. Well, it's not essentially a direct drive. It is a direct drive. I think we're almost done. 98. Last couple of layers.
Last layer, I think.
Says it's down to the last. Oh, it has got a countdown as well. It's got a time elapsed and a countdown of how much it estimates. Pretty static on the temperatures, so it's holding its temperatures pretty well. So it's doing these last couple of layers. Unfortunately, in their slicer, which is just a Cura branch, it doesn't actually tell you. It doesn't actually tell you what version of Cura they're using.
Done.
It's done, is it? As soon as I walk away. The swine! Right. Let's take a little look then. So we open the door. We pull out the magnetic sheet. That's... it's a muy el fuego! Oh, well, that sticks to the... Oh, it's just air. Okay. So we'll just... Jesus. All right. Well, there's not an issue with adhesion, I can tell you that much. Oh, Christ.
Might need to cool that down a bit.
Yeah. Right, so we've definitely got a little bit of elephant's foot on there. So I think we need to use that little block thing to make sure that we are actually the right height. But I mean, that has gone down pretty nicely. And let's see if we can... Hold on. Okay, so how are we going to do that?
Turn the light off on the printer.
Turn the light off on the printer. And then we zoom. Oh, right there. Excellent. Right, so that, as you can see, is not too shabby. Hi, Carl. Nice sides. A nice X. and a very nice top layer. So the only issue that we've got, you can see there, we've got a little bit of elephant's foot. You can see there where it's just squished too much. So we didn't follow the instructions. We just literally stuck the print on. So I think what we need to do is we need to use one of those little shoes to just make sure. Hold on, let's zoom this back out. There we go. Yeah, there is a little bit of ringing on the X now you mention it. So if I go, if I get that in the right light, there is a little bit of ringing on the X and a little bit on the Y. Now that's interesting because that's printing at 40 millimeters a second. So if it's printing at 40 millimeters a second and it's ringing, I'll be interested to see what it does when you increase that speed. If you go up to, if you go up to 60, 70, 80 millimeters a second, I'd be interested to see what it does when it does that. But all of that, hold on. And there. All of that will have to wait for our actual review because, oh, Jesus, well, it's a very powerful magnetic bed light. There we go. So, initial thoughts. Build quality. Let's go back here. There we go. Well, the build, that's the claim. The claim on the site is 300 millimeters a second. I mean, you won't get 300 millimeters a second on a cube. Do you know what I mean? You just won't be able to do that. But we'll definitely do some high tests. We'll do some high speed tests. See how they come out. We'll do all of that as part of the review. If the manufacturer is claiming that 300 millimeters a second is doable, then we're going to test it, and we'll see. We'll put that claim to the test. Final thoughts are: it's very nice looking. It is packed with features. It's got, it's got the changeable hot end. Okay, that's obviously the standout piece, but it's also got auto bed leveling, direct drive. It's fully enclosed. It's lit. It's got the filament sensor on the back. It's linear rails. It's super silent. It's got a it looks cool. It's got a AC heated bed. It's got a sort of semi-filtered fan. Semi-filtered. I wouldn't put it to the test. Like I wouldn't be sucking the fumes out the bottom of the thing, but or the ABS fumes, yeah. It's ticking a lot of boxes. It's got a lot of things going for it. Keep an eye on the channel, guys, because we are definitely going to be doing a full review of this. We'll more than likely do a few videos on it. It's a very interesting machine. It's not something that we've tested before. So we'll definitely be going over a few bits and pieces. We'll definitely be trying to get, so we'll fit this 400-degree brick, and we will be doing some high temperature filaments. And then we'll see how everything goes. Thank you very, very much for joining us, guys and dolls. We're going to end the stream there. So thanks very much for joining. Do not forget to like and subscribe. And we will see you all very, very soon. We are on our way to 2,500 subscribers. And when we get there, we're going to have a competition. It's going to be such a party. I've got a smoke machine. Hold on. Wait. Yes! This will be going, and we'll have a laser.
Lasers.
We'll have lasers.
Maybe a water fountain.
Maybe. Oh, it burns. Oh, that's okay. I'll see you guys later. I need a nap. Bye.